Day 11 of 365 focused on prefix sums, and this felt like the first array topic where a small amount of preparation clearly paid off. The main idea is simple. Store the running total at each index so I do not need to recompute the same partial sums again and again. That sounds small, but it changes the cost and the clarity of several problems immediately. The cleanest example is range sum queries. Without prefix sums, every query can become another scan over part of the array. With a prefix array, the answer usually becomes one subtraction, with a tiny edge case check when the range starts at 0. That is a great example of precomputation paying for itself. I spend linear time once, and later answers become almost mechanical. What mattered to me there was not only the speed up, it was the shift in mindset. I stopped treating each query like a fresh problem and started treating the array as something I could pre-process into a more useful representation. That is an important systems habit too. A little setup work can make repeated reads much cheaper. The second topic was subarray sum equals k, and this is where prefix sums got more interesting. I am still tracking running totals, but now I also care about how many times earlier totals have appeared. If the current running sum minus k has been seen before, then those earlier positions define subarrays that reach the target sum. That turns a brute force enumeration problem into a running state problem. I like that because it showed prefix sums are not just for direct range lookup. They are also a way to represent history compactly. At each index, the running total summarizes everything up to that point. Pair that with a hash map of previous totals, and I can count target subarrays as I move forward instead of checking every possible start and end pair. The third topic was equilibrium index, where the sum on the left side equals the sum on the right side. This example made prefix thinking feel intuitive. I want to know how much has accumulated before the index and how much remains after it. Once those values match, I have found the balancing point. That is a nice reminder that prefix-style reasoning is often about making hidden structure visible, not only about saving time. Another useful part of today was seeing the trade-off clearly. Building the prefix information still costs of in time and often extra space. That is fine if I expect multiple queries or if the transformed state makes the logic much cleaner. It would be overkill for a single tiny question if the direct solution were already trivial. So the technique is not magic. It is a deliberate trade. Do some work once so later operations become cheaper and simpler. That trade shows up everywhere in engineering. Caches, indexes, materialized views, and summary tables all follow the same broad idea. Prefix sums are an early DSA version of that lesson. I spend setup effort to avoid repeating expensive work later. Seeing that connection made the topic feel much more practical than a standard interview pattern I was supposed to memorize. Another thing I liked is that today's 3 problems all use the same core concept in different ways. Range sums use prefix values for direct subtraction. Subarray sum equals k combines them with frequency counting. Equilibrium index uses them to reason about balance. That makes prefix sums a useful pattern to study because one small idea opens several different problem types. So my main takeaway from day 11 was that prefix sums are really about stored state. One linear pre-processing pass can change the shape of future work. Repeated scans become one subtraction. Target sum counting becomes a history matching problem. Balance checks become explicit. That is what made today useful. I was not just learning a formula. I was learning when it is worth paying a setup cost once so later queries become faster, cleaner, and easier to explain. It also changed how I read array prompts, because I now ask whether the problem is really requesting stored history instead of repeated summation every time. Before writing any loop,